Okay, Mr. Hunt here with surface area of prisms and cylinders. Let's jump right in. I got the surface area of a prism formula down for you. Main thing to note, this is super key as it's often missed. Capital B. There's a difference between little b and capital B. Little b is like the base of a triangle, like this side right there. Capital B is base area. Base area. So it's the area of a two-dimensional polygon, like the area of the base of a prism. So maybe a rectangular prism. So it's the rectangle area. Okay, that is huge. Make sure to note capital B is base area. All right, so let's see here. Now you've probably done the surface area of the prism formula. I'm sorry, you've probably not done the formula. You've probably done where you just add up all the faces of a prism, which is fine. And if you want to do that, you can do that, but here's the simpler formula. And let me just explain where we get it from. Well, if you have this is for any prism. Let's say it's a rectangular prism. 2B, well, you have two bases that are the same. And you can actually pick, as long as they're parallel and congruent, those can be your bases for a prism. So for rectangular, I can pick top and bottom, right and left, or front and back. For other, maybe octagonal prism, you got to choose the octagons. Now, if I would have chosen the left and right or front and back, notice that these values over here would change. They'd be different. Okay, so you could have different setup but still get the same result. Okay, so let's see. And then you got perimeter, capital P perimeter times the height. Now, sometimes students wonder what happens to this P, this perimeter. Well, if you were doing all of the rectangles around the side here, so sorry, it's meant to go. Okay, imagine we're doing all these rectangles around the side. Well, what would you do? Let's say that it's a square prism, base of 6 and the heights are 4. Yeah, look, that's fine. Let's change that. Sorry. Let's just change it to like 5 rectangular prisms. So these are 5, and in the back it's 6. Forget the right one. 6, yeah, height of 4. Well, anyways, what would you do? You do 6 times 4 and plus 5 times 4 for this right rectangle, and then the back one is, let's see, 6 times the height of 4 plus, and then on the left side, 5 times 4. So instead of doing all of that, we're really just factoring out a 4, which is 4 is going to be your height from above. And then what's left is the 6 plus 5 plus 6 plus 5. And guys, that's the perimeter. Okay, that part's the perimeter. So it boils down to a formula that instead of adding up all of them separately, perimeter times the height. Okay, so that's the background for the surface area prism formula. I don't think I gave you a spot on there to do that, but it's good to write down if you're curious and you can look back. Here's the one I did have you write down, and this one hopefully your teacher has shown you before. How do we derive derivation? How do we derive the formula for surface area of a cylinder? I just showed you basically the one for a prism. And notice there's really no proofs in this unit, but there are how to derive a formula. So you will need to know that for your test, how to derive a formula. Let's see, so surface area of a cylinder. Remember nets? You probably did those. Should have done those a lot in the past. Here's an example of a net. It's probably not going to be terribly accurate, but a net for a cylinder. And what does it boil down to? It has two circles, top and bottom, and then a rectangle. Let me write down this formula from above. It's actually going to be the exact same formula for the area of a prism, surface area of a prism, except your bases, we know, are circles, so we have 2 of those, and those are pi r squared, plus, and then here's what happens with that rectangle. Hopefully your teacher's unfolded, if you just fold a piece of paper, I don't know if I'm going to be able to draw it very well. But if you fold a piece of paper, that's not good, and unravel it, trying to go from there to there. If you unravel it, and then, okay, fold it back up, it's going to be the rectangle around the sides. So what is the rectangle's width? Right here. Oh, right there. It actually will be, change the color. It'll actually be the distance around the circle, which is perimeter. All right, so it's the same here. And what's perimeter of a circle? It's 2 pi r. And then you have the h, and that is simply, the height of the cylinder. So there you go. Basically, as it boils down to, you got 2 circles, and then you've got, this is circumference of a circle times the height of the cylinder. Okay, let's do some examples. I recommend you can try these on your own, or you can look along with me as we do them. Here we go. So example 1a. You got 8, 16, 18. Find the surface area of the figure. Now, you could do all these separately, but I'm going to do the formula so you can see how to practice it. 2 capital B plus P times H. Capital B, well, it doesn't matter what B I use. I can use front, top and bottom, front and back, left and right. Probably for these, most of you will just say, let's use the kind of traditional top and bottom. So then you've got 18, capital B, I like to do it off to the side, is 18 times 16, and that should be 288. Let's see, yeah. That's 288. Okay, and then plus perimeter. Now here's another thing I should point out. Capital P means perimeter of the base. So I should point that out, perimeter of the base. And that's 18 plus 16 plus 18 plus 16. So that should be 68. And then the height is 8. Notice the height doesn't always have to be up and down. Like if this was on a different face, that 8 would not be up and down. Also, if we had chosen, let's say instead I had chosen the left and the right as my bases, then guess what? The 18 would actually be my height. It's really the segment that takes it into 3 dimensions that we haven't used yet. Okay, so let's see if I can go back to this. So this is going to be, let me just work it out from here. 576 plus 544. 1120 squared units. Okay, part B. This one, there is something new in here. That's why I put this one on here. We're going to have to do area of a regular figure, because you'll notice that it's a hexagonal prism. Let's see if I can draw this very well. Okay, so we get the idea here. Hexagonal prism, they're all 4, the sides up here, so that means it's regular. So it's really something from our past, but I'll show you what we can do here. So let's start off. The formula is 2 capital B base area plus, well, we can go do the perimeter of the base. You've got 4 is 1 times 6 sides. So it's going to be 24. And then the height of the prism is 9. So all we need is capital B. Okay, and to get capital B, let's think about this. If any regular figure, you can always break it up into, there we go, but congruent triangles. Any regular polygon. All right, so I can break it up. There are 6 equilateral triangles. Here's all I'm going to do. I'm going to find the area of one triangle and multiply by 6. If it was octagon, I multiply by 8. Quadrilateral, multiply by 4. So it'd be a square. Okay, so let's do that. So 1/2. Now the triangle, if I can make it bigger, just one of those triangles. The whole base is 4. Here's what I'm going to do. We need that base and the height. So I'm going to draw on the height. And to do that, we've seen this before. This whole 4, it's going to separate that base into 2. 2 and 2. I'll make a right angle here. Let's see if I can do it. There we go, good. I've got 2 with a right angle. So then we have the base, we just need this height, and you got to figure out one of these angles. And I'm going to figure out this one. Look up at the figure here. I know that all the way around that center is 360. And so if I divide by the number of angles, since they're all the same, I can get this angle at the top. So this whole each of these angles at the top of the triangle is 60, but I just cut it in half, so this is 30. Now, this breaks down to 30, 60, 90. It won't always. Sometimes it'll be 45, 45, 90. If it's another angle like 20, 35, something else, then you'll have to do trig to find the height. But this one, I say it's 30, 60, 90, so the height is radical 3 times as big. So let's go back. Area of the triangle, the entire base, not 2, 4. That's a common mistake. Students want to write that the base is 2. Well, it's the whole base. And then the height is 2 radical 3. So half of 4 is 2. And 2 times 2 radical 3. So that's 4 radical 3. Now, that was the area of one triangle. So to get the entire area of that hexagon, multiply by 6. I'm going to put it up here, 24 radical 3. So ready? Here's my final answer. It says leave your answer in terms of pi. 2 times 24, I have 48 radical 3, plus, and then I multiply those out, it's 216. Again, squared units. Okay, feel free to pause, look back at that one. I know there was some new stuff there. I'm going to finish up the last 2. On C, first cylinder, since this is pointing to the, since it's listed in the middle, that 6 is the entire, let's see if I can get it here, entire diameter. So we're going to have a radius of 3. And this is listed as 10, that diagonal part of 10. Well, notice that we have a right cylinder. It's supposed to be marked that way. So we can assume it's straight up and down. That's a right angle. Now, let me go and write out the formula for surface area of a cylinder. Same as before, but we'll plug in the pi r squared and the 2 pi r here. So really the only 2 things you need are radius and height to find the surface area of a prism. Radius is 3 over there. So I'm going to plug that in here. And then 3 there. And then the height, anybody see it? Here's the height. Pause it a second if you can, just to try and determine the height. You'll notice it makes a right triangle where this whole diameter is 6. That diagonal is 10, so we can do Pythagorean theorem to find height, or it's a 3, 4, 5 times 2, 6, 8, 10. So that height's going to be 8. You also could have done Pythagorean theorem. Okay, so let's multiply it out. I do 3 squared is 9. 9 times 2 is 18. Notice it says leave it in terms of pi, so I leave that pi there. Then I do 2 times 3 times 8, that's 48. And pi. So now, just like 18x plus 48x would be 66x, this would be 66 pi. And again, units squared. Okay, feel free to pause again. I'm going to do the last example. Okay, example 2. Find the radius, the base of a right cylinder if the surface area is 128 and the height is 12. Guys, basically this is one of those work backwards problems. You write down the formula, you plug in what you know. They give us that the surface area here is 128 pi. You plug in what you know, and then you find what you need. You'll probably hear me say that a lot. Plug in the values you know, solve for what you need. Let's see, we don't have radius. That's what we want, so I'll leave that there. But we do have height, which is 12. So here's what I'm going to do. I'm going to work it out a little bit, and then we'll be able to solve for our radius. First, let's just 12 times 2 over there. 24 pi r. Now here's something I can do now or later. I'll go ahead and do it now. They all have a pi in them, right? So I essentially can just cancel out a pi. We're essentially dividing every single term by pi, and they go away. Okay, so we could know that now or later. You could also factor it out, but we're not going to need it, so I went ahead and there we go. Is that right? Yeah. Went ahead and got rid of it. Okay, but now look at it. We have a r squared term, an r, and a constant, so I'm going to be able to factor. I'm going to get the 128 on the other side, so I'm going to subtract 128. I'm going to factor out a 2 now, divide everything by 2. And now it's in a better form to factor. Kind of running out of room, so I'm going to go to the next page here. 0 equals 2, and I can factor it into an r minus 4 and an r plus 16. So we set each of those equal to 0, and we get 4 and negative 16. Can the radius be negative? No. So we throw that one out. The radius is 4 centimeters. Okay, that's it for surface area of prisms and cylinders. Thanks for watching.